So welcome to 4C. Hope you guys had a good trip in today. Hopefully the weather clears up. I mean, we have some fun activities planned for everybody at night, so really hoping that kind of clears up. So the first thing we are going to do, everybody's favorite thing, is intros, right? So got to get to know each other. The one thing that we like to do in all of our SAGE classes, if you've never been to a SAGE training before, is we like a lot of interaction. So I know it's early, it's Monday, everybody's tired, but hopefully you guys have lots of good questions, and don't be shy. So I'll go first. I'm Emily Barron. I've been with SAGE for about a year and a half now. I came from Marathon, their Detroit refinery. I was there for 10 years and primarily did all of their BWON work. So I've got a lot of experience and hopefully can answer all of your good questions. And then we're going to go out through the room. The other thing I'd like to know when you're introducing yourself, I want to know if you're new to BWON, if you're an old veteran just looking for, to brush up on your skills, kind of how long, and any specific questions that you have regarding BWON. And I'm going to write them down, so hopefully we get them answered, make sure we get them answered throughout the day. So anything that you're particularly interested in or anything like that. So I'm going to start in the back with my cohort. Brian, you want to start?
I'm Brian Wynn. I've been with SAGE for about 5 years now, and I've dealt with BWON for about 4 years. So that's, and I'm just here to hopefully teach you guys and, hopefully be able to answer your questions or at least be able to guide you to the right directions.
This is Brian's first time teaching this with me, so, just bear with us. The transitions, I'm not used to, I have a loud voice, so I don't really like the mic, so we'll have to, just bear with us, so. You don't have to stand if you don't want to, but whatever you want to do.
My name is Todd Zinda. I'm with the state of Michigan. And I'm new to BWON. I've been with the state.
I'm going to set this down.
My name is Oleg Yasmin. I'm with Environmental Intellect. I'm new to BWON, and I've been in this industry for about 1 year.
I like newbies. Newbies are fun.
I'm Selma Madison. I'm with Marathon Petroleum, and I am raising BWON.
Yeah. Whoever.
Lauren Swear with ISS. Sort of new to BWON. I've done some sampling, but I've been with the company for about 9 years.
Okay.
So hoping to learn a lot.
Excellent.
Elaine Lopez with Valero Slippers. I've been in industry about 17, 18 years. I've
Great.
been chemical and refinery, but new to BWON.
Okay.
I get some more details on BWON.
Yeah, it's funny how people, when you're kind of in the industry, that how many people don't really touch BWON until they're like 15 years into their career, and then they get it.
I'm Pat Gillis with Environmental Systems Corporation. We're a gas vendor.
Great.
We're new to BWON, and we're just trying to learn the basics.
Okay, lots of basics. That's good.
Hi, I'm Laura Garber. I'm with ExxonMobil. I've been with the company for about 2 years, but I'm also new to BWON.
Okay, great.
Randy Roberts, I'm an environmental engineer, air permitting for BASF down in Freeport, Texas.
Awesome, welcome.
Only been with them about 8 months.
Oh.
Prior to that, my career was in titanium manufacture and copper mining.
Very cool. Different switch for you,
Quite a
that's for
switch.
sure.
Charlie Bennett, I'm with ISS. I've been in Eldor for 17 years, just trying to learn a little bit more about BWON.
Excellent.
Oh, I forgot, new to B1.
New to BWON,
Yeah.
okay. I figured the 8 months
Yeah.
was, kind of was a giveaway.
Carla Cook, I'm with ISS. Been there about 8 months, but I've been in the industry for about 14 years.
Okay.
And new to BWON.
Okay.
Jason Corbello with ISS. Been in LDAR for 20 years. Dabbled in BWON.
Awesome. We'll go up to the front of the room.
Mark McCauley. I'm new to B1 with Flint Hills Resources.
Great.
Bill Cundy, I work at the same site in Minnesota with Mark McCulley there. I'm an MLC. I've been LDAR for about 5 years, and B1, I'm just kind of learning it now, and I help with the tagging operations and everything the technicians write up.
Excellent. Okay.
Excuse me, I got the microphone for you. Can you
Yeah,
wear that?
I know. just not using it while we do intros.
Oh, okay.
Then I'm gonna hand it off.
Okay, you want to do it that way? That works fine.
Yeah.
Makes sense to me.
Go ahead.
I'm Jay Christopher. I'm with Tri-Hydro Corporation. I've been with Tri-Hydro about 4 years, but I'm a 30-year industry environmental guy, mostly downstream. I was at the environmental manager at Suncor Refinery in Denver and Conoco way back years before that, and an old hand at BWON.
Great. Well, we can lean on you then.
Todd Morrison with Insight Environmental. Been in the industry about 15 years, relatively new to BWON, more
Okay.
time in Eldar. And
All right. That's normally the way it goes. It's Eldar first and then B1. Start you off in Eldar.
Eric Roylance, Sinclair Refining in Casper. I'm with BWON.
Okay, great.
Member Garcia, Seiko, Corpus Christi, new to be.
Okay.
Kent Stovey, Holly Frontier, new to BWON for about 2 years, in the industry 22 years.
Excellent.
Rennie Small, Holly Frontier. I've been in Eldar for almost 10 years. B1 for about a year and a half, relatively new.
Great.
I'm Danny Shea, I'm with Sage. I have 2-year air permitting experience. I'm new to B1.
I'm Mike Garrett from Calumet Refining in San Antonio. I've got 4.5 years in B1 and retired from Dow Chemical in Freeport, Texas.
Aha.
After 29 years.
Robin Plaisel, University of Victoria, Texas, production supervisor. Just want to expand my knowledge of B1.
Great. Oh, we missed you.
That's on purpose. I'm Cindy Schillinger with Invista Victoria, and I'm environmental, but I'm also cross-training in the B1.
Okay, great. All right, so it sounds like we are mostly new, except for one experienced guy over here who's going to correct us if we make any mistakes. You guys don't have any specific questions off what's on your mind? What's scary about B1?
Well, just one question.
Yes.
This is a full day training?
Yes.
That's okay.
Yes.
I saw the 8 to 12 on the board coming in, and
I think that's just like the morning. We break around 12 for lunch.
Okay, very good.
So we will give you lots of breaks. So, just, but I also do not mind if you need to get up and use the restroom or anything like that. There's water in the back of the room. But hopefully this is a good class for you guys, lots of newbies, so hopefully you have lots of good questions. And we will get started. I'm going to hand it off to Ryan. And you get to use the mic. Yeah.
Sounds good.
We don't normally use mics, so this is very strange to me.
This is all new to us.
I also didn't know that the class was recorded, so, it's not for today.
Everybody hear me?
Loud and clear.
All right, so on our agenda right now is rules, history, and background, and then as well as definitions, applicability, compliance options, control, treatment requirements, and then at the end, a question-answered open forum kind of reception. So we can kind of discuss things that comes up.
Please just stop us if you guys have questions.
Yeah. Yeah, feel free to stop us. Okay. So what is this? Does anybody know what this is? Benzene, right? So benzene is a 6-carbon cyclic hydrocarbon, and then has alternating single and double bonds. Do I need it? Move it down my tie. Then keep this in the back. Let's keep this in the back. I don't either. I just don't want to leave this. All right. So, is that better? All right. So, let's see. So, let's just move on. So, can anyone figure out who this handsome young man is? Or handsome chap is? Does anybody know? Any guesses? Nobody? All right, so this is August Frederick Kukuli. He's the one that's given credit to discovering benzene in 1865. So the interesting thing about him was, I'm gonna have to actually read this off. There's this whole background about him, and I know how interesting he is, but so he was said in an account that he dozed off in a chemistry lab, and in his dream, the black balls of carbon turned into black imps with forked tails that began racing around the room and would soon be upsetting the apparatus of the laboratory. He said that he was ready to run the rascals out, then almost suddenly the confusion died away as each imp grabbed the tail of the one ahead of him, the 6 imps thereby forming a whirling circle. One hand of each imp held a tail, the other a white handkerchief, and they waved to him as a group rolled by. So at this point, he came to wake up with a start, realizing that the imps were acting out the formula for benzene. So then he started sketching it out. So it was all in his dream that these things were grabbing each other, and then he goes, oh wait, it's benzene. So obviously, the insanity of BWON started a long time ago, not just 18 years ago, when the first version of the rule was promulgated. With this, let's talk a little bit about the history of BWON and where we now, the insanity lives on. Is that supposed to be in that section? Yeah, I was gonna say. All right, so BWON Mile High overall. So it's a unique rule that's a cross between an air rule and a water rule. And it's intended to basically reduce the benzene air emissions from the wastewater. So common acronyms are B1, which is Benzene Waste Operations NESHAP, BQ, which is B1, or benzene quantity, TAB, which is total annual benzene quantity, NESHAP, which is National Emission Standards for Hazardous Air Pollutants, and POG, which is point of generation, and WMU, which is a waste management unit. So, let's see. So kind of overall, the rule has different sections where you have applicability, definition, standard general, control treatments, standards for WMUs, treatment standards. You guys have kind of gone through the rule, or at least read the rule, I'm assuming, right? You guys have all at least grazed past the rule. I don't need to go through this too much. So refresher of B1 applicability. So whose facility has the largest tab? And whose has the lowest? So does anyone have? Yeah. So
Do you know what their tab numbers are?
does anyone have like a number of who's got the largest, or who wants to claim they have the largest?
Where's 2 tabs?
2BQ. Okay. 15 for the tab. Does anyone? Yeah. Does anyone else have? 7, 8. I know chemical plants, it can be. So right now, I think Ken's got the largest one, 15, right? As a refiner. So who's got the lowest, I guess? So 7, is that the lowest I heard? Or does someone not even have to report?
Has everybody triggered B1 in this room?
Yeah, has everyone triggered B1? Okay. So, Ken, I guess for you, what's your guys' largest B1 waste streams? It bounces back and forth from the desalter, going to the wastewater plant, stuff like, and then the coker. Okay. The coker also, it funnels back to the main wastewater. Okay, so the coker and the desalter. Okay. So, kind of go through B1 applicability. So if your tab's over 10, if it's larger than 10, which in some mostly refineries, you'll have to report the tab and be under 2BQ or 6BQ, as you were saying, 2BQ. And if it's between 1 and 10, you'll just have to report just the tab. So no controls will have to be implemented into that process until you trigger past 10. And if it's under 1, then basically there's no reporting. You can keep a report there just as a safety precaution in case you trigger, but for the most part, there's no need to have one. B1 applicability determination. So control and treatment standards are potentially applicable to refineries, chemical plants, RECRA, treatment, storage, or TSDFs, co-byproduct recovery plants. And the control and treatment standards are based on the TAB. And so the TAB is the total annual mass of benzene contained in waste determined at a point of generation. So kind of go through the rules and background. So in September 14, 1989, the rule was initially proposed, and then it was promulgated, the initial rule promulgation in 1990, and then in 1991, there was a reconsideration, and then there was a lawsuit in 1991 with Conoco, Sun, and Exxon, and API settlement in 91, and EPA proposed the rule stay in December 9th, 1991. And to kind of keep going through, the rule stayed and amendments were proposed in March 5th of 1992. The rule amendment promulgated and stayed lifted January 7th of 1993. But then the EPA had a benzene NESHAP FAQ handbook in September of 97. The first petroleum refinery consent decree was from Koch Industries, which was December 22nd, 2000. And then the draft rule clarifications was in 2007. And there could be some future rule amendments and clarifications that are coming up. So fundamental questions of BWON. What is the TAB? What is a point of generation? And what is waste under BWON? So in the next slides, we'll kind of walk through these fundamental questions. So what is a TAB? It's definitely, it's not the diet soda, but defined under 61.342, it's the sum of the annual benzene quantities to each waste stream at the facility that has greater than 10% of water, or that is mixed in with water or other waste when it eventually mixes in downstream. Where is the point of waste generation? So the location is where the TAB determination must be made. It's where it exits a process vessel, and then that is integral to process, so process vessel, and then prior to a treatment process, and then that is not integral to a production process. No, I'm kind of. And so the location is prior to handling and treatment of waste. So it's leaving a process vessel before treatment. So let's say a storage vessel, for instance, or a stripper. So when it goes to a storage tank, so it's leaving like the water going to a storage tank, a surge tank, for instance. And so here's kind of a picture. So can you figure out where the point of generation would be? What do you guys? So right here? Right here? Okay, so this one going into the wastewater tank. So that is correct. That's
Does that
what.
make sense, everybody?
Yeah.
We could give some more.
Yeah, we'll do some breakouts. So what is waste under B1? Waste is defined as under 61.341 as a material that is discarded or is being accumulated, stored, or physically, chemically, or biologically treated prior to being discarded, recycled, or discharged. B1's definition of waste is different than under RCRA. For example, recycled material can still be considered waste as at their POG under B1. So it would still need to be reported under your waste shipped off-site. Wastes are considered to be recycled once they are fed to a process as a feedstock and are fed to a process feed tank. Prior to, during recycle, wastes are regulated by B1. After recycle, wastes are no longer regulated by B1. So remember that waste in forms of gas or vapor and field gas systems aren't regulated by B1. It's just mainly water or solids that are being. And so B1 control applicability thresholds. If your tab is under 1 megagram, there's no controls required. Basically, you must report when changes cause the facility to exceed 1 megagram. And if you're in between a 1 megagram to 10 megagram, you're basically, there's no controls required, but you'll have to report an annual tab. And if it's greater than 10, then that's when your control treatment monitoring requirements will be applicable. So noting that 1 megagram is equal to 2,205 pounds. So the tab is calculated in this methodology, typically. It's basically, the tab is equal to the sum of the annual waste quantity times the concentration of benzene that specific waste is, that waste stream is, and basically how many numbers of streams containing greater than 10%. So it includes oil and aqueous phases of each stream. So we'll get a little bit more into this with the breakout sessions, so you guys can practice this. So determining benzene concentrations. So some of you said that you've done some sampling, Lauren. So sampling it per 40 CFR 61355 C3. Basically, there needs to be 3 representative samples with minimal exposures to atmosphere. So once that gets sampled, you just need to cap that, make sure there's no, bubbles and such. And it could be 3 as in once per month, or it could be once per quarter of 3 samples. So the samples also need to be chilled to less than 10 degrees Celsius or 50 degrees Fahrenheit with a sample coil. And it needs to be analyzed per methods 820, or 80-20, 80-21, 82-40, 82-60, 602, or 624. The compliance samples must follow the standard and EBU inlet samplings treatment demonstrations. So kind of an example of what a B1 cooler looks like. This is a smaller one for the most part, but you have your fitting that you'll hook up to, let's say, a bleed valve, or kind of a fitting off of like a bleed valve right here, and then you'll have kind of your outlet. So you'll run your samples through the cooler, let it sit, and then you'll have to purge a certain volume before you actually take your samples. And you have to also make sure that it's to the certain temperature as well. Yeah. You could, but just in case if there are spikes. Emily, do you agree?
Most people just go ahead and take them one time a month. But it's probably better to take it in the beginning of the month, so that if you do have a spike, you can average it out.
Yeah.
But when I ran the B1 program, we did it weekly, and that was, just for averaging purposes. We actually tested food for the treatment, so you want to get a B1 well, make sure that everything's tested well. But, the requirement is, and I've always seen like you do 3 samples all at the same time, and you put those up. Once a month, recommended.
So determining the benzene concentrations. So kind of using the knowledge of waste. Some examples mention the rule as material balance, records of chemical purchases, and then previous testing results. And then some other examples would be sampling that doesn't really meet the requirements of 613355, some process modeling data, product intermediate specifications. So that could be, you can find that through your labs, because since they do samplings themselves, and then organic aqueous interface, benzenes, solubility data, and source of data must be properly documented. So all those chain of custodies and lab results must be kind of kept in hand. So concentration rule by thumb. So if the oil phase is known, but the aqueous phase isn't known, typically a kind of a rule of thumb would be the aqueous phase is equal to the oil phase divided by 100. And the basis for this rule is kind of based on the effective benzene solubility, and generally a conservative estimate of aqueous phase benzene concentration. So it's not a conservative estimate of the oil phase benzene if a calculation is reversed. So another way, kind of, if you knew your aqueous and you didn't know your oil, would be taking the oil phase. The oil phase would basically be 120 times your aqueous phase. So aqueous benzenes aren't normally greater than 1400 or to 1600 ppm. That's kind of a rule of thumb that you can kind of use. Determining tab waste. So the highest annual quantity of waste generated from the past 5 years of historical records, the maximum design capacity of waste management unit measurement that are respectively of maximum waste generation rates. The measurement is not defined in B1, so in practice it includes traditional forms of measurement like the bucket test, time to fill waste management unit of a known size.
So it's literally the time it takes to fill a 5-gallon pail.
Yeah.
You sit there, maybe you have a tap on, and you're saying, okay, that's going to be my flow rate. So that's what we mean by the bucket test. It's very simple way of documenting that.
Okay, so some exceptions for tab accounting would be remediation waste isn't required to be in the tab calculations. It does need to be included in your 6BQ, but not in your tab, or 2BQ. Waste generated by turnaround activities may be averaged over the turnaround cycle for the tab determination. So you could average it within the 5 years, or you could just take it with your each year if you'd like, but that could cause it's a spike certain years. Let's say you had a big turnaround, so you can average it upon the 5 years. Waste streams that contain no benzene and have no potentials to contain benzene aren't counted towards the tab or included in the tab itself. Streams that are less than 10% of water by volume and does not mix, so it doesn't, let's say, go into your oily water system or API system at the end of it all, then it doesn't need to be accounted for in your tab. And then streams containing 10% of ppm of sulfur or ammonia, which is managed in a closed system. So your sour water systems, that basically doesn't need to be, you don't need to account from that where it goes. You would count for it at the exit of your stripper. So your sour water strippers, the exit of that would be where you count for your POG, rather than all the streams going into your sour water stripper.
So, and about that one, any idea why investors like EPA would choose to exempt remediation waste? So remediation waste, they actually exempted that in tab accounting because they didn't want to deter you guys from actually cleaning up any kind of remediation. So the important thing, like Brian said, is it's exempt from tab accounting only, but not from your compliance option. So we're getting into that a little bit later, but I just think that's kind of interesting that at least EPA kind of thought and kind of forced that to try to give you guys a break when you're doing that from your remediation standpoint. Because remediation can be a large quantity, right? It really could be a big stream if you have to take it on the tab. So they didn't want to deter that from happening so that you were to try to stay up below the 10 so you weren't actually triggering B1.
All right. So here's kind of your closer look of what it looks like. So you have your sour water stripper, and then let's say you have your sour water knockout drum, and then it goes into a surge drum, and then it feeds the stripper itself. So for the most part, you'd be accounting for the exit of your water, but the water's going to your desalters. So you'd be accounting, your sour water would just be running through where you'd be accounting your sour water here at your exit of your desalters. So we'll go ahead and have a breakout session. So.
Okay, so the way this works, everybody's got a calculator. We're going to have you do some tab calculations. In the back of your book, there's a section for your breakout.
Yeah. So I know you guys don't have your Excel to plug and chug everything in, so we'll have to do it by hand.
So what we're doing in this breakout is we are trying to calculate the tab quantity. We're giving you some information. We've got a sulfur screen. We've got a tank water draw. We've got a recovery waste.
waste in 5 years, average.
Average it over a 5-year period.
Yeah.
Right there. Page 7. Well, you still have to do one of the between turn around ways to get roll every time you take that. It's less than.
Yeah, I'm looking at this here.
He was only waste quantity. Annual waste quantity. Physically. Okay. A lot of them, like the first one would be it's got a clay pattern. Okay, watch it. The concentration. Go back to back to sort of
So C is ppm by weight, okay, as shown here. Quantity is megagrams per year. And so C. Sulfur.
What do you see known streams?
Sulfur's used.
What?
What do you see the known streams? Part of the equation. Okay, so that's what it is. Okay. So there's already a.
We have a choice as to which aqueous or organic would be used to make What is, would you,
Yes.
A newbie question here.
Yes.
How do we know whether we use the aqueous or the organic waste stream tap calculation?
Well, what goes into the tap? You use both. But yeah, you need both of them. So you have to do it for the aqueous phase, and you have to do it for the
Well,
organic.
they're radically different results.
Yes.
So which do you use, the higher of the two?
You have to do it for both. So you have to calculate a benzene quantity for the organic phase and then a separate one for the aqueous phase.
Both separate.
Yeah. Yeah.
Right, but one is orders of magnitude different than the other. So which is
Both.
both?
Yes. Yep. I'm tracking down some calculators for you.
So I calculate the aqueous phase.
Yep.
And then organic.
Yep.
So this is just some total.
Yes.
That's what you did before.
Yes, for that one. I gotta do all for the other one. Yep, that's
And
exactly
then
right.
once you do this one, then sum them all together for the.
Yep.
So
Yep.
we'll make
So let me put the,
well, we used to complicate it.
this. So this is your tab calculation, remember guys? So it's your quantity times your concentration, okay? And then you have to add them all up. And you have to include both the oil and the aqueous phases. Were we mean to you on this one? Oh no, I guess we weren't too mean. Watch the units, because that's what's good, catches most people. Have to do some unit conversion. Divide by.
Because it's our remediation.
Anybody got an answer? Still working? Yep. So all you do is, for the turnaround waste, guys, what we're trying to get at is that you can average your 10 megagrams over a 5-year period, so divide by 5. And add it to your total.
I got roughly 5, 4.9.
Yep. We will give you the answer.
You divide by what?
Long enough.
BWON, around themselves like a million times. Here, we're gonna reference this other rag that
What do you do with the total? After you add all these together? Oh.
Once you do that,
I have
you
a
do it
blue
this
box
way.
here. And then I tab them all up.
Some of those.
Is this thing on? Okay. For your quarterly reports and from your consent decree standpoint, you've got all kinds of different reports, right? So you've got your end-of-line samples that have to go in there. Yeah, you've got your 6BQ or 2BQ that you're doing in there. And that is where the remediation waste kind of circles back around. Right. Right. Okay. Any guesses? Who's this? Who are these nice people up here? I don't know if it's in your book. It probably is. This is Michael and Sarah Faraday. And see, we at Sage, we just get kind of silly, you know. Everybody wants to get back to their BWON regs. So Michael Faraday actually was responsible for discovering that benzene was a ring. So that's what he's kind of famous for actually discovering. So I had no idea. I thought, you know, Michael Faraday, isn't he? He's a physics guy, right? So he's apparently dabbled in some chemistry too. Okay. Here's where your compliance options are starting to come in. So first thing you do when you have a benzene program is you calculate the tab. If you're over what number? 10. You start triggering these, right? So here are your different compliance options. Anybody use a 1 megagram compliance option? I've actually never seen that. So there is actually a 1 megagram per year target. It is not generally used. It's not favored by EPA. Second one is the segregate and treat option, the 2BQ. And we said we had a 2BQer over there. And then treat to target 6 megagram. Most people are probably 6 in the room, right? How many 6s do we got? How many? Any other 2s besides? Just one, 2. Okay. The 6BQ is actually EPA's preferred method, and it's because it's easier to calculate. It's easier to calculate. It's easier from a compliance standpoint for EPA to review. So that's kind of where they like to have you guys fall. So 2BQ compliance options. This is a control of non-exempt waste streams until treated or recycled. Okay, you calculate these waste streams at your point of generation. So that's important. We're going to go through an exercise where I'm going to make you kind of review what you're looking at here. So you may select waste streams to exempt from control and treat as long as the benzene quantity is benzene quantity from those waste streams at the point of generation sums less than 2 megagrams. So that's what this really is. That's your limit. Your 2BQ, your 2 megagrams per year. Thank you. Is your limit for this compliance option. And then less than 10 weight percent ppm, you can actually exempt those streams and you don't have to count them towards your 2BQ. So that's a little bit tricky here. So this is the only option where you have this treat to target of this 10 ppm value. So keep that in the back of your heads, again, for the exercise that's coming up. And then you have to do these exemptions. You must demonstrate them at least annually. So most of the time, you're going to do the 10 ppm sampling. You're going to use those lovely VOA vials. And you're going to use your sample coil, and you're going to test for this 10 ppm, and you have to at least do it annually. Make sense? 2BQ is a little more confusing than 6BQ, so most of you are 6, so. 2BQ is an uncontrolled turnaround waste, must be counted towards your 2BQ except waste streams totaling the year generated. So no averaging on your 2BQ. Okay. Uncontrolled remediation waste must be counted towards the 2BQ. So again, some of these exemptions that were there before for your tab accounting go away when you're actually talking about your compliance options. So just keep that in mind. Uncontrolled organic waste streams. What's organic? Okay, yes. What's the definition of organic waste under BWON? Less than 10% water. Okay. Must be counted towards the 2BQ exempt waste stream total. So you have to, again, count that. Okay? All right, 6BQ. The facility may select to control treat streams as necessary as long as uncontrolled benzene quantity sums to less than 6. So that's your limit, is now you're at the 6. See why people like this option a little bit better? It's a little easier, you know, got a little bit more wiggle room when it's 6. So you don't have the same exemptions. There's no less than 10 ppm benzene stream exemption. So if it's got benzene in it and it's an uncontrolled stream, which we'll talk about later on how you control your streams, you have to count it. There's no de minimis quantity in benzene either, so just keep that in mind. The uncontrolled benzene quantity for each waste stream is counted at the point where it enters the first uncontrolled waste management unit. So where do you count your 2BQ? Where do you start counting that? Your point of generation? 6BQ is the first uncontrolled waste management unit. So it's a little bit different accounting method, okay? Point of 6BQ accounting may be located at a POG, but it may be downstream of a POG. So this is where P&IDs start becoming really important for BWON. Most of the time we're used to looking at P&IDs for LDAR, right? Everybody's got those lovely highlighted streams for all of their P&IDs. It becomes really important in benzene waste because of this right there. So it's a little bit easier to see when you're looking at a drawing where that POG and where to start accounting when you're looking at it, okay? Treated wastes must be counted where they enter the first uncontrolled waste management unit or where they are sent off-site. Everybody get that? Where they are sent off-site. So what does this mean to everybody? What else do you have to include in your 6BQs? Yeah, your waste shipped off-site. And that can be a huge number if you're not careful, okay? The other thing about this is when you're shipping waste off-site, who else is applicable to BWON? Your TSDFs, right? So if your TSDFs, if you're trying to count a stream as controlled and your TSDF is not controlling your benzene stream, you have to count it to your tab and to your 6BQ numbers. Does that make sense?
What kind of documentation do you need?
That's a good question. Most of the time I've seen it where actually the TSDFs will include it on your manifest. They will include it on your profile. But then if they are actually going to control it and treat it on site, you need a letter back from them saying that they are controlling your waste.
For everything, for each shipment, or just in general?
Most of the time it's each stream. So that's why I think they do it as, you know, on the waste profiles. So, but the other thing is there's, when you're treating stuff, you have to keep records of basically that you're meeting the compliance standards, so like the 98% combustion efficiency if they're using a thermal desorption unit and things like that. So you need those results back from them because you have to count that 2% that they're not destroying. Okay, make sense? All right. I think I covered that one. Organic waste streams must be controlled until treated or recycled in accordance with that citation up there. That is a 6BQ reg. I'm not going to regurgitate all of that stuff. The classic treatment standards and demonstrations do not apply to treatment at 6BQ facilities. So what this means is when you're actually having like a treatment, the only time you get credit for it under BWON is if you're using the 2BQ compliance option. 6BQ, you do not get credit for treating your waste. It's all about your quantity. Benzene quantity under the 6BQ option is considered a running total during the reporting year, and compliance cannot be reestablished. So once you're 6BQ, you're 6BQ. They don't want you switching around to the different compliance options. EPA's, I kind of mentioned this already, this is EPA's favorite compliance option. It's easier to evaluate, and there's no less than 10 ppm exemption. Questions?
Can you go from 2BQ to 6BQ?
Yes, you can, but you can only do it once. Other questions? Okay.
Sure, in 6PQ, that's it.
Well, that's it.
Even if you can demonstrate you're falling below that.
Yep. Absolutely. Yep. Once you're above that 10 megagrams per year, you're triggered BWON, and then once you've picked your compliance option, you have to stick with it, with the 6BQ. You can go back. You can go from the 2 to the 6. Because sometimes initially, if you've just recently triggered for BWON, the 2BQ can be a little easier from just an operating standpoint. So it might not take as much capital kind of money to spend to get you to a 2. But eventually EPA is kind of like, you'll see in some of the consent decrees, they actually force refiners to go to 6 because they like it better. All right, 2 BQ versus 6 BQ, the bucket metaphor. Here's our lovely bucket again, right? So 2 BQ gets 2 buckets. 1 bucket for all uncontrolled waste greater than 10 ppm, 2 megagrams per year, and then they get 1 bucket for uncontrolled less than 10 ppm that could be of infinite size. So if you are less than 10 ppm, you can have a million streams out there and not hit your 2 megagrams. They don't count. They're completely, I don't care, it's less than 10. But what do you have to do on an annual basis? Sample. Yep, you got to prove it. 6 BQ, you get 1 bucket. And that goes all of your uncontrolled waste regardless of your concentration, right? So there's no de minimis quantity of benzene under BWON for 6 BQ. Okay? We like buckets too, I don't know. So we tried to make it a little easy for you guys. This is in your binder. This is our quick reference guide on what you need to do, right? So here is included in the tab, included in 6 BQ, included in 2 BQ. So that hopefully we tried to make it out, lay it out in a nice table so you don't actually have to, we were talking about reading regs back there, you don't actually have to read the reg. So here you have the uncontrolled streams. This is where it becomes really important. Look at all of those yeses. So this is kind of just a quick reference for you. Make sense? Any questions on here?
So define control and
We will. What's important to remember on the 6 BQ is if you have organic waste less than 10 ppm, or I'm sorry, less than 10% water, you what? Have to control it. You don't get an option. So aqueous, you do. You have that option to either control it or leave it uncontrolled, and then it counts towards your 6 BQ. Questions? Okay. All right. We're going to do an exercise. Here is where I need my lovely markers. So again, we're flipping back to the back of your book. I think I'll use blue. I need a drawing so I know what I'm drawing. Okay, let's see. Okay. So you should have probably about 5 different sheets in the back of your book that looks like this with a bunch of tanks on it and letters and all that good stuff. Oh, I'm going to just turn this off. Maybe. Okay. All right. So we are up to two BQ treatment standards. So again, we've got this 10 ppm without dilution kind of threshold. So you have to remove the benzene. Removes at 99% or more benzene on a mass basis. So in order for it to be considered a treatment option, it has to remove 99% of the benzene. You can use an EBU, an enhanced biodegradation unit. So all your aeration basins, you can use this as a treatment unit. But you got to meet that, right? So keep that in mind if you're actually using that exemption. Other options, deep well injection, RCRA permitted combustion, POTWs, etc. You can use those as treatment options. We don't see those as much, but just something to kind of keep in mind there. Treatment equipment must meet BWON control requirements except for EBUs. So if you're using that EBU, then it kind of stops at that EBU after that. If you're proving it's this, then it kind of stops for you. Requires regular monitoring of treatment device operating parameters, e.g. monthly benzene stripper outlet streams, EBUs inlet stream. We've kind of talked about that, right? That's all of that lovely sampling with your VOAs. And then the 6BQ compliance option does not require compliance with the treatment standards. Why? You're already doing it, but where do you count? How are you accounting for your 6BQ compliance? Just with your concentrations, right? You don't really have this whole 10 ppm threshold, so you don't really care as much. We use that term loosely. EBUs, so your activated sludge process, that is a suspended growth process that generates biomass, uses recycled biomass, or periodically removes biomass from the process. That's straight from the reg. Allowable treatment process for 2BQ if your inlet stream is less than 10 ppm benzene. Under the 6BQ, controlled waste streams entering an EBU are not counted towards the 6BQ if combined EBU stream inlet is less than 10 ppm benzene. We're going to use that in the schematic over here. Hopefully it makes a little more sense for you. Typical operating parameters, food to microorganism ratio. I'm not going to read those. Mixed liquor suspended and residence time 3 to 36 hours. So those are some requirements under B1. Yes?
Microorganisms are eating the benzene and
yes.
something else, and that's why.
Yes, correct, correct.
But you still have to measure it, right? Your EBUs.
The inlet, yes, you do. Yes, yes, yes. Okay, we're going to go back to our lovely schematic, and I'm going to change things on you. And I'm going to turn the mic off because it does not like to be next to the speaker. Okay. All right, don't look at your books. Fun facts. How many federal rules either refer to or cross-reference BWON or vice versa? Can you name them? We talked about a few of them. QQQ. Well, Method 21 is what regulation? Eldar. KV. RECRA. GGG. Yep, flares. What else we got? There's a lot. HON, ethylene MACT. I mean, you've got MACT-CC, MACT-DD, QQQ. You guys got a lot of them.
But we haven't gone over all of them, right?
No, and we're not going to. No, no, no. I am not going to talk about every one of these. All right, here's some more did you knows. Did you know that benzene was used as a dry cleaning agent in the mid-19th century and replaced turpentine oil because it had a better smell? Did you know that both the German and Russian words for gasoline was benzene? It's kind of funny when you think about our history and how far we've come with benzene and why they started caring about it, right? So it's a pretty serious rule. So we're clipping along. So we're going to go into round 2 because I think you would rather get out earlier this afternoon. And we're going to play some Jeopardy. So there's a little, some fun this afternoon. But I'm going to let Brian take over and kind of cover some record keeping right before lunch. We'll get it done before lunch because it's the really boring part. Nobody likes record keeping. And then we'll end the day with all of this good stuff over here. Yes. I made Brian do all the non-fun stuff. Oh, yeah. Okay.
Right. All right, so we can start talking about record keeping. So part 2 is going to be record keeping, reporting. Let's see. Record keeping, reporting, waste stream documentation, commonly missed waste streams, BWON provisions of consent decrees, common problematic deficiencies, emerging BWON issues, and then final questions Q&A session. So record keeping and reporting, why is this so important? This is how you determine compliance or demonstrate compliance. Records represent your face to inspectors, and reports are your primary way of communicating to the EPA. So consolidating all of your BWON records in one place is probably the best way to handle your records while preparing for your tab. So tab and uncontrolled benzene quantity waste streams records. Waste streams identify and control status at the point of waste generation. Data and calculations to support the annual waste quantities, stream basically the benzene quantities, the minimum and maximum benzene quantities, and then the oil versus water fractions, and the annual benzene quantities. It also identifies and supports data for the 6BQ streams that are controlled at the point of generation or waste generation and later becomes uncontrolled. Inspections and monitoring records. So failure records showing that waste management units, the location, the dates for each failed visual inspections or NDE monitoring events, descriptions of the corrective actions, and the date of repairs for each failed piece of equipment identified. And although records that demonstrate that the inspections have occurred are not required, they are recommended. IME must certify it as being completed in BWON quarterly reports. So records of all the Method 21, the sniffing testing are required, so just having records of all that, just in case. For each closed vent system and controlled device, facilities are required to demonstrate compliance at the controlled device through one of the following methods. So either engineering calculations or performance tests. All control devices must have a statement signed and dated by the owner or operator certifying that the controlled vent system and control device is designed to operate the documented performance level when the WMU is vented to the control system. And if the engineering calculations are being used to determine the control device performances, then the facility is required to maintain a design documentation. So device-specific specifications, drawings, schematics, piping, or PNIDs.
Everyone have control device documentation? You mean like initial performance test, sure.
Yeah.
Yeah, performance test, or your 20% count, or your carbon. Yeah, okay, I'm getting to that, that's a big one. Okay.
That or it might be something to consider.
You are required to have that, so make sure if you don't have it, you have to go back and look at all your monitoring data and generate it.
So,
That can be considered part of our if you don't have it, yes. Yeah, absolutely.
okay. So for carbon absorption systems that does not regenerate the carbon bed directly on site in the control device, such as carbon canisters, you need to have the vent stream composition and constituent concentration, the flow rate, temperature, and relative humidity, the design exhaust vent stream organic compound concentration level, or the design exhaust vent stream benzene concentration level, and then the capacity of the carbon bed, the type of work capacity of absorbed carbons being used for the carbon beds, and then the design carbon replacement intervals. So how often replacing it before it breaks. Control device treatment system operating records, basically having the dates of your shutdowns and startups, descriptions of operating parameters being monitored, monitoring data that indicates deviations from just normal operating conditions, periods when units is not in operations as designed, and then control device bypass records. So there's a lot of record keeping to have on hand. So you guys all know that the benzene annual report, or the TAB report, is due April 7th for the previous calendar year. The TAB waste stream information and estimates are on there. The 6BQ or 2BQ uncontrolled exempt waste stream lists and benzene quantity estimates. And then the report pretty much summarizes all, and the report will summarize all the inspection monitoring failures and the corrective actions taken. The quarterly reports are being submitted on the calendar quarter basis within 30 days of the end of the quarter, certified that all inspection monitoring has been completed, and then reporting any periods where the control device or treatment device monitoring was out of the regulatory range. So flare pilot outages, EBU, inlet sampling, benzene stripper outlet sampling. It also includes reporting seal gap measurements on the floating roof oil and water separators that are out of range, and then the floating roof tank seal gap measurements based on KV that are outside the regulatory limits. So making sure that all that's included in your quarterlies. Yeah.
I think we do tank seal gap measurements on an annual basis.
Okay.
And yet we have to report quarterly.
Report in the quarter that you've done the inspection.
Okay.
So you're not required to report it if you haven't done it. Because you're right, especially if you're following KD, if you have an annual inspection requirement. Basically, it's just to make sure it goes in your B1 quarterly along with those big inspections. Yeah.
Okay. So waste stream identification toolbox, quote unquote. The PNIDs and PFDs, any process knowledge from your operators or your process engineers, or sitting down with them and seeing how much specific things are being sent to the water sewers, such. Process design documentation, field walkthroughs, observations of operator rounds, and then an MOC program for new and change waste streams. So these are just basically ways to keep your waste streams up to date. So they'll include the waste stream identification, the control status, the water content, the waste stream type. So whether it's a processed wastewater, product tank, drawdown, or landfill leachate. Is that all right? All right, and the annual waste quantity, the water and oil phase, the range of the benzene concentrations, minimum and maximum of the oil and water phase, the flow-weighted average of the benzene concentration, oil and water phase, and the annual benzene quantity. So your waste quantity is determined on the process knowledge, the design documentations, discussions with operators and engineers familiar with the waste generating frequencies and the flow measurements. So sitting down with your operators or your process engineers and asking them, hey, how often are you sending this to the waste, to oil, water, sewers, or how often are you sampling specific things for your own? Document even any evidence of waste quantities, field observations, and bucket tests. So as we mentioned, the 5-gallon bucket, you can perform that, or you can even, if you're trying to figure out the oil versus water, you can use a flask, Erlenmeyer flask, and just let it sit and settle. What else could I use?
How about your rule of thumb?
Yeah.
You don't know that kind of stuff. Make sure that you're documenting that. Most of the time, that should be right with all of your tab documentation. So I've seen it in one big, huge spreadsheet most of the time, right? Where you've got it kind of all the way across the row, where you've got all of these things that Brian's kind of describing that's pointed out for each stream. You have to have it for each benzene waste in that stream. So it becomes really kind of a labor-intensive kind of operation. But it's really important because it is required to be there, to be part of that.
So it could also be just a rule of thumb of, I talked to the operator, and he said that it's about, give or take. That's perfectly fine. Your desalters accordingly, so some examples would be like an operator would say, according to the crude unit engineers, the design waste water wash rate is 5%, and the design unit charges 180,000 barrels per day. Therefore, the annual waste quantity for the water phase is, so you would take your unit charge rate multiplied by your percent of design water wash rate multiplied by the conversion of gallons, barrels times the conversion of pounds to gallons, and then 365 days in a year, the conversion of pounds to megagrams, and you get 522 megagrams per year. So how would you account for the oil fraction of this waste? Times 110. Well, you would take your oil phase, which would be the other one, right? What was that? Yeah.
Yeah, this is a quantity question, which I always screw up when I'm I just think it should be concentration.
So it's, did we hear that one? We good?
Everybody understand that? What we're asking for? How do you get the quantity based off of that information that you know, according to your salter? What else would you do? Put your boots on and go talk to the operator? They should be able to tell you, right? Yeah, you can do that too.
So benzene concentration data, there's oil phase concentration data sources. So products and intermediate modeling data, or HYSYS. ISIS.
Everybody use process models for their B1 test. I don't see this very often from B1 test. Most of the time I see this environmental people, we kind of just like to let the tech service people. They can play with those models. We don't use them very often. But you can use it. It's a good way to verify data.
Or you could be using sampling data, MSDS, or product specifications. Water phase concentration data sources, you can use waste stream sampling, B1 sampling, using the B1 sampling protocol. Rule of thumbs where the water phase is approximately 1/100th of the oil phase concentration, and then just make sure to be documenting the basis for the benzene concentrations in both oil and water phases. So let's tie everything together. So, back to the books. So the scenario is a tank water draw. You have a gasoline tank water draw where 5,000 gallons per month is water drawn from this tank on average, where there's approximately a 5% oil undercarry, and the gasoline benzene concentration is 15,000 ppm, and 1 gallon of water equals 3.8 kilograms, and 1 gallon of gasoline equals 2.8 kilograms. So what we want to know is what's the contribution of the tab in megagrams, and what is the contribution of the uncontrolled benzene quantity, or the 6BQ, in megagrams, as well as the 2BQ in megagrams. So we did have calculators go all around, so it's going to be one calculator per table, if you guys want to use that. And hint, hint, it's going to an open, oily water sewer.